All right, so thank you so much for waiting. We apologize for the inconvenience. And again, welcome to our webinar today. And this is... All right, so thank you so much for waiting. We apologize for the inconvenience. And again, welcome. Okay, so apologize for that. I apologize for that. All right, so welcome again to our webinar on blue carbon ecosystems. This serves as our 65th non-online initiative under the Climate Education Nexus. So before we start, I will introduce you on the Climate Educate project and what is our project all about. Okay, so to introduce you to our project, so let's try a short poll. Okay, so first, how well do you know about blue carbon ecosystems? Okay, so in order for you to answer this question, please go to bit.ly/blue carbon poll. Again, please go to bit.ly/blue carbon poll. Okay, so I will send the link to everyone and we will see if how well do you know about blue carbon ecosystems. Okay. All right, so now if you're done voting, we can see if everyone voted already. Okay, so some of you have some idea already and some don't. And then, okay, good. All right. So there are 13 people who answered already. Okay. Okay. All right. Okay. So we're still waiting for the others to answer. Okay. So we have 21 people. Okay. All right, so you can see it here on the poll. Okay, so there are 22 people who answered already. And most of you have some partial idea on blue carbon ecosystems. All right, thank you so much. Okay. Now, let's go back. All right, so again, to introduce you on our project, so Climate Educate is a youth-led project launched in 2016. So Climate Educate project is the one who organized this webinar. And we have been doing this for almost 4 years now, since 2016, after our training with former US Vice President and Nobel Peace Prize laureate Al Gore back in March 2016. And then we launched this through the Alpha Team Organization, ATO Incorporated, a Philippines-registered youth nonprofit organization. So currently, we're doing a project with the Climate Reality Australia and Lord Mayor's Charitable Foundation, and this is part of our activities. So unfortunately, because of the pandemic, we have resorted to an option that we will transfer, or we will create online initiatives instead of physical activities that we're used to have. Our non-online initiatives are basically school and outreach activities that are done in more than 13 countries already. Okay, so this is an example of the graphics that we're making. So we usually present climate change education through vector graphics. We have done this since the very beginning of our project, since 2016. So again, blue carbon ecosystems refers to our mangrove forests and seagrass beds. And later, our speakers will explain further about these. So this is our some of our project teams. So this is an example of our recent online output. So in the middle of the pandemic that we are facing right now. So together as one, we rise to fight the pandemic as we continue to save our planet. So aside from doing climate change education initiatives, we have worked previously with Kangwon National University through its EcoPeace Leadership Center in Korea, in South Korea. And we also worked with the United Nations Environment Program regional office in Asia Pacific, which is based in Bangkok. And we also worked with Yuhan Kimberly to do this mangrove reforestation project, which was done back in December 2017 to June 2018. And this was done in Pandan Antica in northern Panay Island. So it's just nearby the famous tourist island Boracay. Okay, so this is our project area. All right. So we have done multiple initiatives to do our blue carbon research as well as building capacity in the local communities. So this project is basically youth-led. Okay, so these are some of our pictures. And our newest project, which is Climate Education Nexus, and is part of this webinar. So currently, this is led by the ATO Climate Educate Project and the Lord Mayor's we're supported by the Climate Reality Project and Lord Mayor's Charitable Foundation. So again, Climate Education Nexus is a collaborative project implemented by the ATO Climate Educate Project, the Climate Reality Project Australia and the Pacific, and Lord Mayor's Charitable Foundation. Okay. So to introduce you to our speakers for today, I will start with another presentation. Okay, so this one is part again of our webinar. And as you can see, one of our project members created this data visualization. So we're very overwhelmed with the number of interested participants. So that's why we closed the registration as early as possible, because our Zoom platform will be able to accommodate only 100, less than 100. So we also gave opportunities for the others who are also interested to join by watching our live stream in our YouTube channel. So we have posted on our Facebook page already. So we have 12 countries, and most of the participants are from the Philippines. We have participants from Japan, Australia, India, Malaysia, Thailand, Nigeria, from Denmark, and Mexico. So thank you so much for joining us today. All right. Okay, so for our webinar program, I believe that everyone has familiarized this already. Okay, so the first part is a short introduction to Climate Educate Project, and then after this we will have a little bit of a game. Okay, so I think you will like this. So for our speakers, one of our speakers, to introduce you to our speaker one. So Michael Yap is our former regional project manager. So he recently completed his master's degree in seagrass transplanting from University of Malaysia, Sabah. He is a co-founder of Seagrass Guardians, honorary member of Alpha Team Organization, and a member of Climate Educate Project. He is a former project advocacy head for Malaysia and regional manager for East Asia, Southeast Asia, and the Pacific Regional Hub. He had been studying and conducted research in seagrass ecology and restoration, and promotes restoration and protection of seagrass or blue carbon ecosystems in mitigating climate change. From 2017 until the present, he had conducted and invited, he had been invited to at least 40 talks already, and multiple exhibition and research workshops. And he shared his work in seagrass and climate change. And he has contributed to our project, which made him a project member of the year in 2018 for East Asia, Southeast Asia, and the Pacific. So our second speaker is Ms. Wang Zini, or Ms. Lucy Wang. She is currently a communication assistant for the Education for Sustainable Development program of WWF Malaysia. She is an affiliated member of Malaysian Youth Delegation and our scientific advisor for the Alpha Team Organization Climate Educate project. And as an environmental science degree graduate, her focus of study is on climate change, biodiversity, conservation, and marine ecosystem. She also has a research background in remote sensing and GIS on marine pollution. And she also has internship experience with Indonesia Mansa project on Elasma branch and blue ecosystem conservation. Her current pursuit is to strengthen the game of communication on conservation science through her own experience and explore innovative mediums to attract a wider audience into the biodiversity conservation issue. So we have a very good set of speakers today, and they have been well experienced in the field. So before we start with okay, so to introduce myself, okay, Mr. John Carl Musaga. So currently I'm the project liaison officer. I was the one who was sending the emails. So I also work as a designer and coordinator in ATO Climate Educate project. Okay. So before that, we will have a short game. So just a second, okay. Okay, so we have for those who can join already, we are streaming on YouTube. So if you can tell your friends if they are very interested, then they can watch on our YouTube channel. Thank you. All right, so I think everyone is familiar with quizzes. Okay, so let's have a first game on how to test your basic knowledge uh, on blue carbon ecosystems. Okay, so let's see if anyone is okay. All right. Okay, so I have sent the link already the on the chat, and you can start. You can start on. Okay, you can start on joining. All right. So, okay. Right. So I sent the link on our chat, and then you can check it out. All right. Okay. Is everyone ready? Okay. Still waiting for the others. It will be a very short game. All right. Okay. So if you have trouble accessing the game, so just message us out here in our chat. Okay. All right. So we have one already. Okay. So let's start. Okay, so we only have one player. We're still waiting for the others. All right. So, okay. So I think the others have a problem. So the first question is that which of the following is not part of the ecosystem services provided by seagrass? So we have A, coastal protection, letter B, carbon production, letter C, feeding ground for dugong. Letter C, feeding ground for dugong. Okay, so which of the following ecosystems is not part of the ecosystem services provided by seagrass? So number one, okay, so the answer is letter B, carbon production. Okay, number two. Okay, so all right, everyone. Okay, right, that's good. Okay, number two. How many percentage of oceanic carbon is stored by coastal vegetation ecosystems? All right, what do you think is the answer? All right, number two is letter. Okay, letter B. All right, the answer is letter B. For number three, our oxygen mainly comes from the ocean. What is the main oxygen producer in our ocean? Again, our oxygen mainly comes from the ocean. What is the main oxygen producer in our ocean? So letter A, phytoplankton, letter B, seagrass, letter C, mangrove. All right, so the answer for number four is letter C. Okay, so, all right, so, okay, so there's a lot of mistakes in there. Okay, so the last question will be how much seagrass can a dugong consume in a day? So letter A, 4 kilograms, B, 14 kilograms, letter C, 40 kilograms. What do you think is the answer? Okay, all right, so letter C, okay, for number five, the answer is letter C, 40 kilograms. All right, so thank you so much. All right, so now I will give the floor to Mr. Michael Yap for his presentation on blue carbon ecosystems and provide us insights on his seagrass conservation work. The floor is yours, Michael.
Okay, thank you, Carl. Okay, hi everyone. I hope everyone can hear me clearly. It seems that I might have a little bit internet not that stable as I currently in China. Okay, so this on. Okay, so today I will share more about the blue carbon ecosystem, the seagrass especially. So I will make this short. So most of my talk about the seagrass, you can go to the Jedi Penang's page, which there's a webinar on 7 May 2020. So the video also upload in the YouTube as well. So you can have a look over there. So just make a short summary. So why seagrass is important? First of all, it's a habitat and nursery ground for various of organisms. And in seagrass meadow is in Malaysia, the study have found that juvenile number of fish is higher than in the corals, is up to 35, 10 times, 6 times more juvenile number compared with the coral reef. Secondly, seagrass also the food source for the herbivore, especially the marine endangered species like the dugongs, green turtles. And seagrass also absorb carbon dioxide and produce oxygen. More than half of the oxygen we're breathing now is come from the oceans. And the oxygen is produced mostly by the phytoplanktons. The fourth one, seagrass also help to reduce wave energy. In a way, it will help to reduce the erosion effect of a wave to our shorelines or beach. And seagrass also help to stabilize the sediments so that they maintain a good quality of waters and also reduce erosion to the beach. And finally, seagrass is one of the important carbon storage in our oceans. Okay, so we're passing. And just now in the quiz, a dugong can feed up to 40 kilo of seagrass a day. While green turtles, they feed on seagrass and algae. So they have the options. And green turtles can feed up to 4 kilo of seagrass a day. And after they will feed in the seagrass meadow about 4 to 5 years. Then they will start to migrate back to their breeding ground to lay eggs. After that, they'll move back to the seagrass meadow to fatten up again and then repeat the same process. Okay. So seagrass, how seagrass help to mitigate climate change? The first of all is the blue carbons. Blue carbon is the carbon that's stored by the coastal vegetation's habitat and keep the carbon inside the sediment, which I will explain more in the following slide. Second, seagrass also help to maintain biodiversity of our oceans. And the third one, food security. Because in aquaculture, we are using a lot of antibiotics and so on. So our food is not, food security is always an issue. But if we can protect and conserve our seagrass, it will be a natural breeding ground and nursery ground for the fishery resources, which will produce more balanced and healthy seafood for us to consume. And fourth, seagrass help in coastal protections, especially in mitigate seawater level risings, increasing water temperatures, and also ocean acidifications. Okay. So seagrass have been recognized as second largest carbon sink on the planet. And by seagrass alone, they have a 35 times more effective than terrestrial forests, trapping carbon into the sediments. Because the seagrass, they have a high turnover. Every time when they are photosynthesis, they trap all the carbon dioxide and convert into their plant tissues. Then the old leaf will deposit into the sediment, which will be trapped. Layer by layer of sediment will build up over the time, and it will create a lesser and even zero oxygen environment where the decomposition will be stung. And all those organic carbon will be trapped inside the sediment for millennia, 100,000 a year. So this helps to offset the carbon footprint in the atmosphere. Okay. And in recent study, seagrass restoration have been proven it helped to offset the greenhouse gas. And this is one of the mitigation tools that we should emphasize and conserve our seagrass meadow in mitigate the climate change in the long terms. And from Thailand, one of the projects done by the Thailand researchers, where they found that in 10 years of seagrass conservations, they found that the carbon storage is increasing over the years. Although the number is still lower than the existing natural seagrass meadow, but this is proven that seagrass is a tool that we can use to mitigate climate change by trapping the carbon into the sediments. And this, just now the quiz, that the coastal vegetation only cover about less than 2% of our ocean's area, but it store almost 48% of oxygen, oceanic carbon into those habitats. So what are the coastal vegetation habitat? Those are the salt marshes, mangrove, and seagrass. And some of it, the second speaker will share more with you guys later. Okay, so another way of how seagrass help to mitigate climate change as coastal protectors. So this both illustration just to show you how the seagrass help to reduce the wave energy, stabilize the sediments, and this will help to reduce the wave energy from the ocean to the shoreline. In direct and indirectly, it will help to reduce the wave energies and the erosion effect on our beach. And this will help to protect our properties and even the coastal habitats from destructions. But unfortunately, like all the coastal marine habitat, seagrass also facing degradation. And currently the degradation rate is estimated up to 7% annual globally. So you just imagine that about 2 football field size of seagrass meadow are disappearing every 30 minutes globally. It's quite a lot. And once we losing all these meadows or disturbance between these meadows, it will disturb the sediments and release all those organic carbons back to the atmosphere through the decompositions. And this will accelerating the climate change effect. And what is the cause of the degradation of seagrass meadows? Coastal development through dredging, reclamation, infrastructure buildings. Natural cause like disease. There's a wasting disease which occurred in America in 80s, which kill kilometers of seagrass meadow and they take about 10 years to restore the seagrass meadow up to half, not fully pre-existing, pre-disease outbreak conditions. And seagrass also been destroyed through destructive fishing methods like dredging, trawling, and also from the boat through the anchor damage, where there are no fixed buoy, boat are putting anchor on the seagrass meadow and drag along the seagrass meadow, which will unroot the seagrass as well. And what happened on the land also will affect our oceans, including the seagrass. Conversions of land or deforestation for housings, agriculture, release nutrients, chemicals, pesticides, or river runoff will wash to our coastline, mangrove, seagrass, corals, and up to the open sea. And seagrass, in a way, it will help to mitigate climate change impact. But when the climate change is over their tolerance thresholds, the climate change will become the factor of the degradations to the seagrass as well, like the ocean acidifications, seawater temperature increasing storm and frequencies. Okay. So now the question is, why the conservation of seagrass still lacking? First of all, it's less on media coverage because seagrass is just a grassy appearance and not that attractive compared with corals, which are more colorful, and also lack of awareness because a lot of research and conservation works is focusing on mangrove and corals instead of seagrass. So some of my works published in the Malaysian Naturalist magazine in 2018 in highlighting the importance of seagrass and the blue carbon in mitigate climate change. So answer back to us, what actually all of us can do to help conserve and protect this blue carbon ecosystem in fighting climate change? First of all, support all joint seagrass conservations. There's a various group around the globe. They are working on seagrass conservations, restorations, or even just advocacy. So most of us can join or just help to spread out the word by sharing their posts in our social medias and so on. And if we are visiting seagrass meadows, we try to avoid the propeller of the boat in chopping down the seagrass leaf by trimmings or just by pushing the boat when the water is very shallow. Of course, as a citizen scientist, everyone who are able to identify seagrass can use this app, the Seagrass Spotter. This is a global version where everyone can snap photos of seagrass, upload into the software, and pinpoint where is the locations. And this app is open access, so everyone can access it, even for researchers and conservationists. So this will help to map up the seagrass surrounding our oceans, and we can tackle seagrass conservation more effective because currently we are lacking information, where is the distributions, where the seagrass located, how the condition of the seagrass is, and so on. And this is an example of a local community in protecting their wetlands, the mangrove and the seagrass habitats. And this is from Johor, Malaysia, Club Alami Mungkin Tanjung Kuping. So this is the youth that have been conserve and protect their mangrove and seagrass for 10 years. And currently their age is just around 20 years old. So you imagine they are start from very young. And they are doing a lot of exhibitions, giving talks, conduct ecotourism by bringing researchers to visit mangrove and seagrass, let them understand the habitat and its importance. They're also doing research together with the researchers, either conduct research together or being trained by the researcher. Then they conduct the research and collect the data for the researcher to analyze later. So these are some of the photos they are conducting the research together with the researcher in Malaysia. And through their effort, they can present to authorities or anybody the condition of the seagrass 10 years, 5 years ago compared now. And this help to formulate a better management plan to ensure that the seagrass meadow will be protected, especially the blue carbon storage, which will help to mitigate the climate change. Okay, that's a short sharing from me. So I'll passing this back to Carl.
All right, so thank you so much, Michael. And that was a very interesting presentation about seagrass. For everyone's information, I've been working with Michael since 2016.
16,
and we 16. So we have been advocating for blue carbon ecosystems, and we try. Even though that we haven't met virtually, I mean physically, but we're working virtually for years, and we ask him from time to time regarding blue carbon ecosystems conservation, because we're working on mangrove conservation here in the Philippines, and he's doing seagrass conservation. All right, so thank you so much. So if we have questions, please, you can raise your hand, and then, or you can just send it on the chat. We'll accommodate only 2 questions for now because of the limited time. So we're trying to, keep the time going. All right. So we're open for questions. All right. Okay. So do you have any questions? Okay. All right. Okay. So we have our first question. We only have, okay. Okay, so Michael, this is our first question. How do we engage the youth? This is from Clarence Gio Almoite. Okay, so the first question is, how do we engage the youth in the conservation of seagrasses?
Okay, thank you, Clarence, for the questions. Engaging your youth might be a challenging because maybe due to the age and the education backgrounds. But we always can use a simple infographic sharing with the youth to show them the importance of the seagrass instead of using too scientific data, which they might have difficulties in understanding it. And second would be if we can identify a young leader among the youth and train that leader to become the peer influence among the peers. And this will help to increase the impacts and the engagement of the youth in the conservations. Okay. Hopefully that answer your questions.
All right. Okay. So thank you, Michael. We'll take another question, okay, for the last one, because we have a very limited time. So the next question is from Bong. Okay, so is there a possibility that storing carbon using seagrasses or sediments, as discussed, can alter the water's environment's pH? Like, is there a possibility that it would cause a drastic slide in pH, probably pH acidity? Yeah, okay, that makes water acidic. We all know the effects of water acidification. Okay.
Okay, thank you, Bongs. Currently, there's no scientific research on how the carbon storage might affect the ocean's ocean acidifications. But what happens is when the carbon dioxide concentration is high in the atmosphere, it will absorb in the oceans, which causing the ocean acidifications. But for seagrass, it will absorb the carbon dioxide and trap some of the carbon into the sediment. So in a way, it might help to reduce the water acidification in some way, but we still need more scientific research on it to confirm how this relationship, how seagrass in terms of fighting climate change and also fighting the ocean acidifications. So we still need more research on it. Yeah, thanks.
All right, thank you, Michael. Okay, so,
Yeah.
all right, so, okay, thank you. And we will now proceed to our next presentation. But before that, let's have another game. Okay, so I hope that everyone will be able to participate this time because we have a bit of a crummy first game. All right, so what you will do first is go to quizzes.com and then, okay, all right. So to join the game, click the link. I sent the link already on the group chat. Okay, so the password or the code is 980250. All right. So all right. Okay. Is everyone ready? Okay, 25 player limit. All right. Sorry about that. Yeah. Okay. So I will just try to play and everyone's behalf, and you can send your answers through chat, and let's see if you are correct. And this is the quiz for our next presentation. Okay, so just a second. Quizzes is very good in your classes. Some of you maybe are teachers, so it's a very good tool to engage students online, and especially that all classes are already transferred to distance learning and platform. All right, just a second. Okay, it's if we have a problem, we can just do this manually. All right, so sorry for that. Okay, so again, our first question is that where do coastal wetlands store most of its carbon sequestrated? Okay, so we have letter A, leaves, letter B, roots, Letter C is soil. Again, where do coastal wetlands store most of its carbon sequestrated? Letter A, leaves. Letter B, roots. Letter C, soil. Okay. All right. So let's see. Okay, so the correct answer is letter C. Okay, soil. All right. Okay, everyone got it correct. Almost everyone. All right, number 2. Let's see. Which species gives birth in a mangrove ecosystem and the young stays in the area as nursery grounds? Letter A, sea turtle. Letter B, nurse shark. Letter C, octopus. Let's see. Mhm. Number 2. Okay, some answered letter A. Sam answered letter B. All right, so the answer is letter B, nurse shark. Okay. Number 3, in what form do coastal wetlands store carbon underground? Number 3, in what form do coastal wetlands store carbon underground? Letter A, organic. B, inorganic. C, calcium carbonate. Okay, let's see. Okay, the correct answer is letter A. Almost everyone got it. Okay, good. Number 4, how deep can carbon be stored underground in coastal wetlands? Again, number 4, how deep can carbon be stored underground in coastal wetlands? Letter A, 3 meters. B, 6 meters. Letter C, 10 meters. Okay, let's see on the chat. Mm-hmm. Mm-hmm. Good guess. Some answered letter A. Okay. All right. Mm-hmm. Okay, I guess almost everyone got it wrong. Sorry about that, but the answer is letter B. It's 6 meters. Okay, and the last question. Number 5, what is the condition in the soil that enables coastal wetlands to store carbon up to millennia? Okay, and number 5, what is the condition in the soil that enables coastal wetlands to store carbon up to a millennia? Letter A, aerobic. B, anaerobic. C, high salinity. Okay, let's see on the chat room. Mm-hmm. All right. Okay. All right. Some are answering letter A, some are answering letter B and C. So the correct answer is letter B, anaerobic. All right. So, okay, to show you the answers. Okay, I'm not cheating. All right. So the letter green shows the correct answers, and then the color red shows the wrong answers. All right. Okay. So I will give the floor now to our next presenter, and she is also from Malaysia. And I have worked with her for almost a year now, and she was also my classmate in University of Hawaii East-West Center last year as part of the YCLE Academic Fellowship. And to welcome you, she is Miss Lucy Wong from Malaysia. Okay, Lucy, I give you the floor now.
Hi, Carl. Hi, everyone. Yeah, before I begin, Carl, can you share my slide?
All right. Okay, so just a second, please.
So in a second, so good afternoon to everyone on the line from Malaysia. I'm Lucy from Climate Educate Project. So I'm happy to be invited by Carl to be part of this online initiatives along with Michael to share about the blue carbon ecosystem. So without further ado, let's begin. So on the slide, you can see there is 3 images on the left. There is, you can see on the left image, there is a patch of mangrove extended to the coastal zone. And in the right image, the darker area in the water are basically seagrass growing underneath the crystal clear water. So this is how amazing mangrove and seagrass can do to the water quality in marine environment. So both of the images are taken on a beautiful islands in Indonesia called Rote Islands when I was in the marine conservation internship with Indonesia Menta project. So as for the middle image, you can see there is a floating seaweed on the crystal blue ocean surface. So this is an image that I took on a marine conservation expedition to Alaska, the US, with a Sustainable Ocean Alliance. So these three images are to provide a brief insight into what I'm going to cover today. Since, next slide, please. So since Michael have already provided a wonderful presentation on his research on seagrass meadow, I'm going to focus on the rest of the two blue carbon ecosystem, which are the mangrove and the salt marshes. As Michael mentioned earlier, blue carbon are basically carbon absorbed by marine or coastal ecosystem. It is known for its extraordinary capability to sequestrate carbon into the deep soil. We all know that anthropogenic carbon dioxide is also causing climate change like never before in the history. Hence, it is important for us to work with the nature mechanism to remove the extra carbon dioxide that is just enough to keep our planet warm from the atmosphere. So in the three main blue carbon ecosystem, as you can see in the slide, salt marshes rank the first in their capability to absorb carbon, and followed by mangrove and seagrasses, as shown in the data. So next slide. So before we dive into the unique mechanism of how carbon sequestration works, let's have a brief and basic understanding on mangrove and salt marshes. So these two coastal ecosystems are both found in the intertidal zone. So they are ephemeral in the term of their location, which means they move in response to the changes of sea level. Yeah. So while seagrasses are often found in the infralittoral zone, where they are usually fully submerged and they are considered as a marine plant. So however, mangrove are considered terrestrial plants which adapted to live in salt water. Mangrove can be found mostly, the slide before, this slide, thank you. So mangrove can be found mostly in tropics and subtropics region, where the temperature of soil usually rank between 30 to 40 degrees Celsius, while salt marshes are more common in the temperate region. Of all the carbon absorbed in this ecosystem, 78% is stored in the soil through the process of carbon sequestration, whereas the rest of the 20% in the living trees and roots, like how the terrestrial forests store their carbon. So what makes the blue carbon significantly important as a metaphor to highlight the coastal ecosystem in climate change mitigation tools is their capability to absorb 5 times more carbon in the mangrove. So this data is in conjunction to the total area of respective ecosystem left on the planet, which is the area that the mangrove area that is left on the planet today. So as Michael have mentioned on his data earlier, it is important for us to keep in mind that even to only accounts for 2% of the ocean area, the carbon deposit that is stored in the sediments account for around 50% of the total carbon deposits in the marine sediments. So what contributes to this huge difference is the carbon sequestration mechanism of coastal wetlands, where they store their remaining carbon after the respiration process under the ground in a woody biomass and soil. So under this anaerobic environment, this organic carbon can be stored for a long period of time compared to the above ground structures like leaves and stem. Next slide. So to talk about conservation of this area, we have this principle in conservation biology that we know we couldn't save all the species on the planet, comparing to the rate that they are disappearing from the planet. Hence, it is important to look at the vulnerability and irreplaceability of the area or a single species in terms of their ecosystem services. To identify the priorities conservation area where resources and manpower can be effectively allocated for conservation. Coastal lands like mangrove and salt marshes hit the 2 points for their scarcity and the high richness, unique, and sometimes endemic biodiversity they support. So the most profound function to put on the table is the regulating service, as you can see in the slide, that help to stabilize the climate system and support societal adaptation, where it is also incorporated into the UNFCCC adaptation and mitigation in climate change, which we would briefly cover at the end of the presentation. So however, protection from an ecosystem approach, the slide before this, So however, protection from an ecosystem approach should be emphasized rather than focusing on single species, so that the diversity of habitats and their connectivity is maintained to continue to support the other ecosystem services like the provision services, whereas seafood production is important to achieve mutual benefits of the local community living in the ecosystem and environmental protection. So one of the natural mechanisms worth mentioning is the natural land reclamation process, where the active accumulation of sediments in mangrove and salt marshes leads to the increase in coastal area with no extra cost. So besides, plants in mangrove are also capable to absorb nitrates and phosphate, which leads to the process of cleaning up and restoring water quality near the shore, which brings us back to the first image that I showed in the presentation. It is another natural yet completely free services. Next slide. So why is it important to conserve? As we have talked about the scarcity and effectiveness of carbon sequestration process, let's also not to forget about the vast organic carbon stored underground, which can also cause adverse effect on climate change. If we allow over exploitation on the area, a significant amount of organic carbon that actually stored underground are ready to be oxidized into carbon dioxide when it is released into the atmosphere through exploitation activity. Yeah. Next slide. So some of the threats that are drastically removing this ecosystem from our coastal area are land use changes being the main threat, and followed by anthropogenic pollution like effluent runoff, which at the same time stresses the ecosystem to the brink of collapse in performing their ecosystem services. And also not to forget about timber production from mangrove ecosystem. So studies have showed that the rampant exploitation of these ecosystem in the last few decades, especially in the Southeast Asia, is due to the traditional mindset of seeing these wetlands as a low value asset, which are commonly targeted to convert it into development site or simply trade off the natural resources in the ecosystem into monetary income with unsustainable practices, which leads us to the loss of more than 50% of mangrove area across the globe today. So despite being incorporated as a tool, for this slide, the last point, climate change. So despite being incorporated as a tool to mitigate climate change, on the other side of the coin, climate change also putting the rate of this ecosystem at risk due to the projection of sea level rise in next decade and extreme weather event which gradually challenge the limit of ecosystem on adaptation to the intensified storm and prolonged flooding or drought happening in the regional area. Yeah, next slide. So coming to the last slide, we are talking about carbon management. How do we manage blue carbon ecosystem in climate change mitigation? So we look at three framework: preservation, restoration, and creation. To preserve is to maintain or enhance the original biogeochemical process, such as sedimentation and water supply, to continue its legacy in natural defense mechanism and breeding ground for vast wetland species. So to restore is to improve the degraded or abandoned area like the aquaculture into its primarily wetlands ecosystem again. So some example of the restoration are the one that Climate Educate project are doing, the restoration of mangrove forests, and also removing hard barriers like eroded seawalls that are not functioning anymore to restore the natural tidal flows as the alternative to coastal flood defense. So this is one of the example of nature-based mechanism that we are going to that UNFCCC has incorporated in its framework to mitigate climate change, to adapt to climate change. So this is where, so the restoration part is where the local NGOs and community are highly encouraged to take part. Yeah. As most of the initiative can be done with the power of people in certain temporal scale without complex systematic intervention. So in creation, this is where the systemic approaches come in, which includes stakeholders from different sectors to sign and create carbon taxation schemes or UNFCCC climate change mitigation mechanisms such as the REDD+ forest restoration into action. However, this top-down approach usually drive great shift in community engagement in the later processes when it is go into implementation. So last but not least, education to coastal community on the value of blue carbon ecosystem is also important to convey the purpose of conservation and introduction of alternative blue ecosystem practices to achieve mutual benefits on the social security and also on ecosystem protection. So yeah, here I am towards the end of my presentation. I hope you guys enjoy it, and yeah, I would like to pass the floor back to Carl. Thank you.
All right, thank you so much, Lucy. And that was a very interesting presentation. Okay, so we are now open for questions from the team or from the audience, I mean. So again, our chief director just reminded us that everyone she would like to request everyone to join on our virtual photo shoot here in Zoom. So you may open your camera later on and then do the climate science. So we will teach you later on. Okay, so I have, okay, I can see a question from, okay, wait. I can see a question from, can you please raise your hand again, please? I can't see it anymore. Or maybe you can send it on the chat. Okay, so maybe I can see it. Okay, or you can open your microphone, you're acknowledged.
Hello, Ma'am Lucy.